Hello, today we are going to be starting chapter 8, which is chemical bonding. In this chapter, we'll cover some of the basics of bonding, such as different bond types, and start drawing our Lewis diagrams for our molecules. And then in the next chapter, chapter 9, we will be talking about the shapes of molecules. So to start with, we need to go over some basic ideas. A bond is the force that holds atoms together in order to make a molecule. And that results from the simultaneous attraction of the valence electrons in one atom to the nucleus of another atom. So we are going to be talking about Coulomb forces, again, talking about the strength of the nucleus and the distance between two atoms. Bond energy is going to be the energy required to break a bond. We will be looking at a calculation for that at the end of the chapter, and that will, show us things like a triple bond is going to be stronger than a single bond, and so on. And then another thing that we'll be talking about is why the compounds are actually formed. And that is because the compounds are going to be energetically more stable. So the system wants to have as low of an energy as possible. With a lower potential energy, it will be more stable. Hopefully you remember from regions our three different types of bonds. So first off, we have an ionic bond. In an ionic bond, our electrons are transferred between a metal and a non-metal. So we are going to have attractions between the positive and the negative ions. And remember, the way that we tell that we have an ionic bond is, again, you will have a metal and a non-metal. The metal will be losing electrons to make a positive ion. The non-metal will be gaining electrons to make a negative ion, and that's why they're attracted to each other. And again, there is a transfer of electrons. With our covalent bonds, covalent, remember, means covalence. So the atoms are sharing their valence electrons. Covalent bonds occur between two nonmetals, and depending on how they share the valence electrons, we can have a polar covalent or a nonpolar covalent bond. Polar is when there is an unequal sharing of the electrons, and nonpolar is when we have an equal sharing of electrons. And that mainly occurs when we have diatomics or triatomics. So with like O2, you have two oxygen atoms, so therefore they would be sharing their electrons equally. And then lastly, metallic bonds occur obviously in metals, and that's where we have the sea of electrons. So there's the metal cations, and then all of the electrons just move freely wherever they are needed. And that's why metals are such good conductors of electricity, because they have free moving charged particles. All right, another thing that hopefully you remember from Regents chemistry is drawing out dot diagrams or Lewis dot diagrams or dot symbols. So we are just going to be drawing dots for our valence electrons. So if we take a look at aluminum, if we look at its placement on the periodic table, aluminum is in group 13, so therefore it will have 3 valence electrons. So we're going to put 1 electron on each side. Next up, we have oxygen. So if we take a look at oxygen on the periodic table, oxygen is in group 16, and oxygen has 6 valence electrons. So we draw 6 dots on here. So 2 of the sides will end up with 2 dots, 2 of the sides will end up with 1 dot. This is going to be very important in a couple of days when we start drawing out the Lewis dot diagrams for our molecules, because we need to know how many valence electrons we're dealing with. Number 3, we have Kr. krypton is a noble gas, group 18, that has 8 valence electrons. So therefore, it is relatively stable. Kr, like all the rest of the noble gases, will exist as a monatomic atom, meaning that it will stay by itself, single atom, because it's already got the 8 valence electrons, making it stable. All right, our last two are ions. So you might remember that when we have ions, we are going to use square brackets. So the way that we start it, sulfur. Sulfur is right below oxygen on the periodic table, so sulfur has 6 valence electrons. Then, because it's the -2 ion, that means it has gained 2 valence electrons, so now it has 8 valence electrons, square brackets, because you put ions in square brackets, and the charge on the outside of the brackets. All right, last one we have is the sodium ion. So sodium, Na, has 1 valence electron. When it's an atom, however, this is the ion. The ion has lost its valence electron, so we draw sodium with no valence electrons, square brackets, and charge on the outside. All right, hopefully we remember that most of the time when the atoms react, they want to gain or lose electrons so that they have 8 valence electrons. That's what we call the octet rule. So they are going to gain or lose electrons in order to get to 8, taking the shorter route so that they end up looking like the noble gases or the closest noble gas. Now, we do have some exceptions there. So if they only have 1 shell, then they wouldn't want 8, they would want 2 valence electrons because 2 would be full for the first shell. So like lithium has 3 total electrons, 2 electrons in the first shell, 1 electron in the second shell. It will lose 1 to end up with just the 2 in the first shell, giving it the same electron configuration as helium has.